Okay, for people in the video, I'm setting a 7.5-minute timer to do part C and D, which we did not do last time. So great luck. I'm here for questions if you missed. Hey Charlie, we're doing the same problem from Friday, like finishing it. Oh. He's trying to copy your head, yeah.
That's fine.
All right. Well, there's your 7.5 minutes. I didn't realize, like, it was bad to do this in 2 different days because I did so much. I was like scrambling to finish in the 7.5 minutes. Because I forgot that they had mentioned something in like the problem, the fact that F has convert radius of 6 to answer part C of D. So watch this. My work won't, because I was scrambling, my work won't really be helpful. Plus, the people in the video can't see it. But if you want to compare yours to mine, there it is. But I'll show you what the scoring guidelines say. But basically, you should have gotten a radius of 6 for C, and that's your F prime. And then for D, you do the ratio test, and you put the cancel a bunch of stuff, and then you should have gotten that x squared is less than 3, which means that x is between these two, like square roots of -3 and 3, and so the radius is the square root of 3. But here's the scoring guidelines. So look at, for part C, you just have to take the derivative, and it looks like confusing and hard to do. Let me try to find the original expression. Sorry. Okay, there it is. This original expression, I think I can draw on it. That's the original expression, and when you take the derivative of that, you got to remember that the only the thing that you're taking the derivative with respect to is this x. So the n's and the 6 to the n and the n squared, you can they're just like the coefficients, so you can kind of just ignore it. It'll just be there in your derivative too. So n plus 1, n squared, 6 to the n. If you were taking all those derivatives, you were taking the derivative of the wrong thing. You only need to take the derivative of the x to the n. So you're going to get n times x to the n minus 1. And in fact, you could just leave it there. Like this could be your derivative. But I canceled this and one of these ends. And then you're also asked what is the radius of convergence of this f prime? So maybe I should make it more clear that that thing is f prime of x equals that stuff. And then you were asked what's the radius of convergence of f prime? And like I said, I forgot that on Friday that I read that f has a radius of convergence of 6. And so f prime also has to have a radius of convergence of 6. So they did not expect you to do a bunch of work for C. In fact, I thought it was weird that they asked find the radius of convergence of this, and then part D says find the radius of convergence again. I was like, why are they asking that twice in a row? That's strange, but I guess that's why, because for this one you didn't have to do any work. Oh shoot, I was trying to highlight. I guess that's on there now. Oh, there, on view. So this one required no work. The next one did require some work because they gave you this new series and they said use the ratio test to find just the radius of convergence, which is nice, which means you don't have to check the endpoints, which saves you a step. Since they just want the radius, the endpoints themselves aren't going to change anything. But for this one, I don't have much to say. You just do the ratio test. Boom, 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 boom. Cancel everything you can, and then you'll get basically this. And that limit, again, because you're going to get some n cubed over some n cubed, the limit is just going to be the x squared over 3, the coefficient basically of the ends. And then this x squared, here they have it. The x squared over 3 has to be less than 1, and then when you solve the thing, you should get that x is between, they wrote it in a weird way, but x is between these two. Like, that's how we would have written it in class. The square root also makes it a little bit funky. Question?
If you like don't write the limit part, like you're just like going as fast as possible, you do the first step and then you just cancel everything out. Like, will you still get points or no?
Yeah, I bet you do. I mean, like, look, if they didn't write the limit up here, the first point is earned by presenting a correct ratio with or without absolute values once earned and can't be lost. First point is also earned for ratios equivalent. First point is very mathematically equivalent. To earn a point, must correctly evaluate using correct limit notation. So yeah, maybe you did. The third point is earned for an answer of square root of 3 with supporting work. That's a good question. Other questions? Okay. If you feel totally, completely like bewildered and lost by these questions, then like you know for sure that this is going to be one of the questions on your test. So it might be worth doing these at home until you get like comfortable with them. Because this is your second one ever, so you might be like, whoa, this is crazy, insane, so hard. But the more you do, the more you realize that they're asking the same thing year after year after year. So I think you'll find a pattern and you'll get good at them. Like you still have a week to get sweet at these. All right, but there's that one. That's a Taylor series one. And since you've done now 2 of these, including the one in class that we did, I thought we'd do another Unit 9 one. So I'm a find. I don't know. We have to predict whether it's going to be polar or if it's going to be parametric. But if I bring up my picture that I showed you guys. Well, okay, I'd have to find that. But if I bring up my picture that I showed you guys, they did like 4 years in a row of parametric and then 1 year of polar. So I don't know if they're gonna do 2 polars in a row or if they're gonna do like go back to parametric. Hard to tell, but maybe we just start with the polar one just to match what they did last year. So I think the last polar one was here. No, this is a velocity. Okay, but that's fine. Okay, let's just do this one. Oh, only 3 parts as well? That's nice. Okay, so try this one then. I'll find a polar one. I think the polar ones were actually before the pandemic, so 2019 and 2018 were polar. But we're already here, so do this one, see what you remember, and then we'll go over the answers. And this is number 2, so you'll for sure need a calculator. Or Desmos, or you could just set up the integrals or whatever. You guys can hold my talent. I saw it. Oh, I don't like this one. I forgot.
I thought we already did this one.
Yeah, you did it if you did the quiz on the back of your homework.
Is this a calculator?
Yeah, that's a calculator one. Okay, so there's a couple kids who already did this, so maybe I stopped. No.
I swear I've seen this problem before.
They just asked the same thing. Like, yeah. Sorry. They just ask the same thing a lot, especially if I look up 2022. Look at, they say the same. Well, they say kind of the same thing. Find the speed, find the acceleration vector, find the y-coordinate of the position, find the total distance. They always ask you.
Oh, yeah.
Oh yeah. Yeah, you're right. But yeah, I guess there's kind of a little bit that goes into this. That is annoying, but the whole process would look like. Well, maybe I can do some other stuff. Starting here, since this is f squared over 3, the absolute value is just doing nothing. So you're actually, this equation is equivalent to just that equation. And so you don't need the negative 3, but even if you did the negative 3, it would be okay. Because, okay, when if you have x, because the absolute value of x is less than 1,
Yeah.
then x would be positive or the yeah, exactly. So the absolute value is doing is not.
So,
Yeah, but then, okay, you're getting this negative. No. You get to this point, and when you take the square root of both sides of it, you get positive and that's where it's negative. What was I getting? I forgot. Okay. Oh, some people did get up your computers. So I'll let this timer go. Maybe I'll go like 5 more minutes. Because from what I see, people are just seeing if they would know how to do this on their computer. Rather than actually getting out your computers and getting the answers, which is fine with me. I think that's a good way.
For a problem like this one, just says find about like 7 functions, then just write the answer.
Yeah, you'd have to show this equals that. Let me bring up the scoring guide. No, actually, let me do this on the.
I don't know, I was really remembering it. This, yeah, this one.
Okay. You want answers or do you want to keep working? Okay, yeah, you can. I'll keep going. Oh, I can find it.
They're all kind of similar. They're all kind of similar.
Okay. Let's go through this. I'm going to cut this off early because most people, like I said, most people were just seeing if they knew how to do it rather than really putting in the numbers in their calculator. But okay, for part A where it says find the speed of the particle, you should have done the magnitude of this vector at 1.2. So square root of that function at 1.2 squared plus this function at 1.2 squared, and you get 1.27 something if you were actually putting them into your calculator. Okay. And then it said, also part A said find the acceleration at 1.2, and it does a nice, like these are kind of nice. I kind of hope you get one of these on the test because I think they're easier than polar, because they kind of give you hints within the problem. Like this one, the speed of the particle, should be a number, so you shouldn't do like something comma something. So you should get this 1.27, like number, scalar, if you're familiar with that word. But then for the acceleration, it says find the acceleration vector, so it's like a hint to you that you're like, your answer should be a vector, meaning, oh yeah, just take the derivative of this dude, and put a 1.2 in, which I had Desmos do. The derivative of the x part is 6.24. The derivative of the g part is 4.05. So your answer for the vector would be 6.24 comma 0.405, which actually maybe I should show you. That's your acceleration vector. Cool.
Why
Okay,
is
let
it-
me zoom into
Why
this.
is it different? Like, why is it for one of them you have to do the magnitude and then the other one you just do the
Because the speed, like by definition, is just like the number, like how fast it's going. Whereas acceleration vector tells you like how fast you're accelerating and in which direction. So it needs to be a vector. Anyway, part B says find the total distance traveled by the particle, and then this is kind of another hint if you're like not super. Where's the question? Oh, here it is. Another hint if you're not super confident on the test is they say find the total distance over some time interval. That should be a little bit of a hint that you're not just plugging in a number, but rather you're taking an integral since they gave you like an interval that you're interested in. So anyway, you should have taken the integral of basically this thing. Here it is. From 0 to 1.2 of your f and g prime. Oh, I think I did that wrong. Slightly, because I forgot that f and g were already the derivative. So I should have just done f and g in my Desmos and gotten 1.009. Let me check that that's right. 1.009. Question.
Why didn't you take like the absolute value if you're trying to like total distance?
Because the square root of that takes that like already like if that's what popped in your brain, then you're right, good job. But the absolute value of this vector function is the magnitude of it. So whoop whoop 1.2. This stuff is the absolute value of a vector. It's like the magnitude of it. Okay, and then part C. Well, are you good on this? Any other questions? All right, then part C. If you didn't do it, then be careful because you may have. Well, if you didn't do it, did you think about what you would have done? Okay, like, because none of you got out your computer. Well, a few of you got out your computers, but most people did not. So I don't know if you like thought in your brain how you would do it, or if you just sat there and waited for the answer. But if it's talking about finding the point furthest to the left of a thing, then that's talking about the position, and it wants you to like the x coordinate to be as small as possible. I hope you agree. Like, this is a particle that's moving around on the plane, and the horizontal movement is given by the x sub t, or sorry, the x of t, and the vertical movement is given by the y of t. So if I want to find out where is it farthest to the left, then I really only care about the x coordinate, and I care about when that's the smallest. Convinced? So therefore, I just want to find out when is this the minimum. In other words, I need to minimize this. Minimize that. Which you would do by, just like minimizing anything else, you would take the derivative of the function, which, nice, they already did for you. Find the candidates for the minimum and maximum, like by finding where that's 0, and then checking your endpoints. Here you only have an endpoint. One endpoint is t equals 0. I'll tell you more about that in a second. But here is my derivative of the x part, my x prime, this t minus 1, whatever. You can see that has a relative minimum at 1, 0. And so that's your candidate for a minimum. You could also talk about how at 0 the function was decreasing, so 0 could not be a minimum. So the minimum had to have happened here at t equals 1. And so it says find the coordinates of the point at which the particle is furthest to the left. So you can't just say the minimum happens at t equals 1. You actually have to go and find the position of this at t equals 1. So there's a lot of layers to this. but the hard part of the problem is finding out, okay, t equals 1, that's where my minimum is. Now you have to go and freaking find the position, which is start plus accumulation. Start right here plus accumulate from 0 to 1, the integral of these two functions. And to save ourselves all that work, here's them doing it. There's their start plus accumulation, and so they get this point is furthest to the left. Did I explain that fine, or should I? Any questions? Summary is find the minimum. The minimum happens at t equals 1, and then find the position at t equals 1, which is itself its own problem because you have to remember to do start plus accumulation. Okay. Anyway, you get this point. Then it also asks, why is there no point furthest to the right, for which the answer in your brain should just be because there's no maximum. Like the function, let me show you the graph. The function keeps increasing and increasing for all times after t is greater than 1. But if you think a little bit logically, it could be that the function looks something like this. I'm talking about just the x coordinates right now. This is the derivative of the function. It has no maximums, but it could be that, you know how 0 started here and then started decreasing and then started increasing again after 1? What they're saying is that could be true, and it still could be true that that's a maximum if it increased like this. Start at 0, decrease, and then increase slowly, like with an asymptote right here, then 0 could still be a maximum. This is why I was saying I don't like this question, because there's so much to this part C that's like, it looks very innocent, but it's really, really hard. So you had to say not only there's no maximums after t equals 0, but also the 0 can't be a maximum because I found this other point that's higher above than 0. So like I said, if you read their model response, it says x prime is greater than 0 for all times greater than 1. In other words, it never has a relative maximum. And also 0, it was not a maximum to start with because I found this other point x equals 2, which is greater than x equals 0. Where did this 2 come from? They just pulled it out of somewhere, like so that to show that x of 2 was bigger than x of 0, so x of 0 could not be a maximum. I think this one is harder than they ask most years, but parts A and B are super easy. The first part of part A, or the first part of part C was not that hard, finding the minimum and then finding the coordinates. So even if you didn't get that maximum part question, like the rightmost position, that was only 1 point. And this would have been 4 points, which is not bad. Question?
I was just going to ask you what the question was.
If I read that right, just talking about the minimum was 4, and then the rightmost one was only 1 point, even though you had to do a whole lot. All right, but that was a lot of words. Maybe if I lost you, you should do the next one. So tomorrow we'll do a particle one and a polar one, and you should actually get out your computers and make the effort to do it. Because you always run into little things about like putting the numbers in right, or am I supposed to integrate or not, or whatever. So tomorrow I say actually do it. But good work today. Hopefully you got something out of this. What's up?
If you go back to